All right, today we're going to be doing the partition list question, right? It's number 86 on LeetCode. So what the question is asking is you're given a linked list, right? And more specific, you're given a head and a value, right? These are the arguments that are being passed throughout the function. And what they want you to do is, using that value, loop through the pre-made linked list, right? And if the values are less than, then you want those values to come in first. And if they're greater than the value in the argument, then they want those to be last, right? So what that's going to look like visually is this right over here is the pre-made list, right? And this is the pre-made list, and this is going to be the list once it's done, right? So you could see, let's say for instance, our target was 3, right? All the values less than 3 come first, and all the values after 3 come second, right? And the reason why 4 is before 3, don't get too tripped up, it's because if you take a look at the pre-made, 4 comes first, right? So it's not in order of less than or greater than. To a sense it is, but the specific values, it's kind of separated in 2, if that's an easier way of thinking it, right? So it's just separated in 2. And I already kind of said the answer out loud, but you're going to do this by checking if the target is less than or if the target is greater than the value, right? Okay, so this is kind of what you're given, right? Like I mentioned, just the head and the target. And how you're supposed to go by this question is by creating 2 different linked lists, right? To create 2 new linked lists, one storing the less than values, one storing the greater than values, and combining them near the end, right? So it holds all of them and it's in order. So how are you going to go and do that? Well, the first thing you do is, like I mentioned, you're going to have to create 2 linked lists. So in order to do that, we're going to create 2 variables, right? So creating 2 linked lists, right? We're going to call one fast underscore node equals node 0, right? And then slow underscore node equals node 0. Okay, perfect. And now below that, we're going to create pointers, right? Because these are starting at the head, right? These are the head of our 2 linked lists, and we want pointers so we could, create more nodes throughout. So we're going to have fast equals fast underscore node, and slow equals slow underscore node. And lastly, we are going to want to create a dummy variable for head, right? And we're going to call that, we'll call that current, right? Current equals head. Perfect. Now for step 2, what we're going to be doing is adding values into these new linked lists, right? So while current, right? Because current is equal to the head, right? Current is this. Current is the pre-made, right? So we're looping through this. While current, we are going to check if current dot value is less than the value given, right? So this is checking for less than, and then we'll just make an else statement down here, and this will be for greater than, right? Perfect. So if it's less than, then what you're going to do is make slow equal to slow dot next, or no. Slow dot next equals current, right? And slow equals slow dot next, right? So we're starting at slow, right? We want the next value, because remember this is the start. We want the next value equal to current, and then we're setting slow to that value we just added, so we're kind of on the same page. And the same thing you're going to do for fast, literally the same exact thing. So fast.next equals current, and fast equals fast.next. Perfect, right? Um, and then obviously we need to iterate through our current, so current dot next. There you go. So these are just adding values, right? So fast node should equal 432, and slow node should equal 122. Now the last step for this is to combine the two linked lists, right? So how are we going to do that? Well, the first thing we have to do is for fast, right? We need to make sure that fast.next equals none, because we already iterate through fast 3 times. Remember, fast is equal to 4, 3, 2. So if we're combining them, we need to make sure that this list ends somewhere, and it's obviously going to end right here, right? So that's exactly what we're doing right here. And then for slow, we're going to do slow.next equals fast underscore node dot next, right? So slow is equal to 1, 2, 2. All we need to do is just add this stuff, right? However, the reason why we do dot next after fast node, because fast node is the head, right? So this is starting here, and it's going to have all these other nodes within it. The reason why we do not next is because of the dummy variables, right? The dummy variables are set to node 0, and we don't want that, right? Like that's just filler. We want to remove that so we get a proper answer. So that's why we do the dot next here. And that's going to play into part with what we're returning, because now slow has all the values, right? And it's all the values we want, and slow is equal to 143252, but it also has that dummy variable we have, right? Remember? So with that being said, we just need to kind of skip that, which we're just going to do right here. Returns slow underscore node dot next, right? So because we did the dot next, what's going to happen is I click run. There you go, right? If I didn't have the dot next, you would see the 0, right? And we want to skip that. Perfect, perfect, perfect. So that's how you do. That is exactly how you do a partition list, right? It's a medium question. It's question 86. This question in particular, obviously you're working with linked list. I would say it kind of reminds me of like the reversing a linked list technique. You have to create a lot of dummy variables and so on, and kind of playing with it in order to get the question done.